Hi, now we are going to see a new chapter, current electricity in detail. The electric current, I, we heard that current is passing because of flow of electrons in a wire. The main concept of current is flow of electrons. When you take a wire, when it is not subjected to any external electric field, the electrons are moving in random direction. The electron present in the wire moving in random direction, the velocity is not zero. It is nearly 10 power 5 meter per second. But it is not constituting the current because electrons are moving in random direction. So it gets cancelled. Okay. Now, when it is subjected to external electric field, that means you are connecting the wire to a battery, positive and negative of the battery. Then the electrons present in the wire, that is called free electrons. The free electrons present in the wire moving towards the positive side of the battery, whereas direction of conventional current, this is direction of current. That means it is opposite to the flow of electrons. Which direction electron is moving, current direction is opposite to that. The simple reason electron charge is negative. Movement of electron only current, but charge of an electron is negative. So the direction is opposite to one another. So how many charges passing per unit time? Charge passing per unit time, we call it as current. I is equal to dq by dt. Rate of flow of charge. I is equal to dq by dt, we call it as current. Unit q by t, capital Q by t also you can write, that is coulombs per second. Coulomb is a unit of charge. Unit of time is second. So coulombs per second or ampere. Ampere is a unit of current. Coulomb per second is also unit. Ampere is also unit. 1 ampere current is passing means 1 coulomb of charge passing per second for 1 second. That is called 1 ampere current. So electric current flowing through a wire means it should be subjected to external electric field. Electrons already possess a velocity. In addition to its velocity, it moves or accelerates towards the positive side of the external electric field. Okay, fine. In the case of electron movement, we are going to talk one more term here, current and drift velocity. Drift velocity represented by V suffix D. Drift velocity. See the name, drifting, accelerating. Electron possess its own velocity. In addition to that, it is getting accelerated towards the positive side. When external electric field is applied, that word should be there. So that is Vd. Acceleration into time. This time we call it as relaxation time. Time here we call it as relaxation. What is called relaxation time, sir? During the motion, when the electrons are moving in the wire, they may collide with one another. Electrons may suffer collision between one another. Between two successive collisions, the time taken, we call it as relaxation time. Accelerated because of external electric field, two collisions. How to calculate total number of distance by total number of collisions. Between any two successive collisions, the time taken by the electrons. Here, acceleration A is equal to force by mass, A by m. By Newton's second law, the force is E and the mass is m. What is called E, sir? We have studied in electrostatics. The electric field and force is given by the formula E is equal to F by Q. F is equal to EQ. That is the amount of force exerted by the electrons inside the wire. Force is a vector. We have to put a negative sign. When you put a vector symbol, negative sign should be there, minus E. So minus EE by M. We call it as acceleration. Therefore, drift velocity will be minus EE by M into tau. Minus EE by M into tau, we call it as drift velocity. Okay. Now, one more term we are going to discuss here. That is mobility, mu, represented by mu. What is mobility? Drift velocity per unit electric field divided by E. Vd by E. So I can write minus E by M into tau. Unit of mu. Velocity meter per second. Electric field, there are two units. Force by charge. So Newton per coulomb. Another formula E is equal to V by R, potential by distance. So volt per meter. So meter square, volt power minus 1, second power minus 1. Unit of mobility. You can very well write in terms of Newton per coulomb also. Okay. So this is drift velocity and mobility of the electron moving in a wire when subjected to external electric field. Okay. Current and drift velocity, what is the relation, sir? Relation between I and Vd. Current and drift velocity relation. Simple. You consider a wire which is in the form of a cylinder. So many free electrons. Assume length of the wire is A, length of the wire is L, area of cross section is A, and this is electron movement, drift velocity, and this is the direction of current. Let n be the number of electrons passing through the wire per unit volume. That means what? For 1 meter cube volume, number of electrons small n, 1 meter cube volume. Therefore, total number of electrons n into AL. Area into length we call it as volume. 1 meter cube it is small n. What is our volume? A into L. So total number of electrons is NAL. Simple. Current is equal to charge by time. Charge is nothing but NE. NE. Total number of Q is equal to NE. We are putting capital N here into E by time. So I can write I is equal to NE by T. What is N? NAL into E by T. Time is nothing but distance by velocity. So I can write NEAL by time is nothing but distance by velocity. Distance here is nothing but length of the wire. By velocity we can put VD. So LL cancels. I is equal to NEA VD. Relation between current and drift velocity. I is equal to NEA VD. Simple equation. Correct, Amma? So this is the equation connecting current and drift velocity. Drift velocity, the velocity acquired by the electrons moving in a wire when subjected to external electric field. Okay. Right now, so we have seen current and drift velocity equation. Next, an important topic, what is called current density. Represented by J. Current density is nothing but current by area. J is equal to I by A. J is equal to I by A. Unit ampere per meter square. This A stands for ampere, this A stands for area. Current density is a vector. Current is a scalar. Why current density is a vector? Current by area. Area actually, suppose you have a sheet. Area, normal of the area this side or normal of the area this side. Which side you are indicating? Normal means perpendicular. So that we call it as current density. Simple. Next. Ohm's law. To indicate or to talk about Ohm's law, we should know first what is the difference between EMF and potential difference. EMF and potential difference, what is the difference? EMF is not a force. First of all, you should understand that it is not a force. It is the work done by taking a unit charge, work done by taking a unit charge from the source, entire circuit to the entire circuit. Potential difference is the work done in taking a unit charge from one point to another point. Suppose you are preparing a cell, Leclanche cell or Daniel cell you are preparing. When you prepare a cell, say the EMF is, the potential is 1.5 volts. When you measure this by a voltmeter, voltmeter is showing 1.5 volt means the internal resistance of the cell is zero, complete freshly prepared cell which has got no internal resistance. So the ions present in the particular cell are free to move when it is subjected to external electric field. Positive ions are moving towards negative of the electrode, negative ions are moving towards the positive side of the electrode. The potential difference between the two is 1.5. So work done in moving a unit charge from one point to another point in the entire circuit. Source, from the source, EMF. Potential difference is also 1.5 volt because no internal resistance. But except the freshly prepared cell at that moment, any other time you take, it has got some internal resistance. So the potential difference, this is EMF. Potential difference is always less than 1.5 because of internal resistance, 1.4, 1.3. Generally, we will write E is equal to or psi V plus IR. V is the potential difference, I is the current passing through, R is the internal resistance. When internal resistance is 0, psi is equal to V. This is EMF. 1.4 plus 0.1. So the current in internal resistance is 0.1. Potential difference measured by the voltmeter is 1.4. Left hand side 1.5 is fixed. Here alone there is a modification. 1.5, 1.3, 1.2. That means internal resistance of a cell may go on increasing as time passes on. EMF of the cell exists even if the circuit is open. But circuit should be closed, then only potential difference will come. EMF is independent of external resistance, what you are connecting. But potential difference depends upon external resistance. So we are going to write this one. This is only Ohm's law. We are going to see. So the current which is passing through the wire, when it is subjected to external electric field, is proportional to the potential difference between the two ends. And main concept here is at constant temperature. At constant temperature, the current passing through the wire is directly proportional to the potential difference. Or I is equal to a constant K into V. K is nothing but 1 by R into V. V is equal to R. So you cannot write potential difference V as product of current and resistance. You have to define at constant temperature the current passing through the wire between the two ends of the conductor is directly proportional to the potential difference. I proportional to V. And V is equal to IR. We call it as Ohm's law. Okay, fine. Next, resistivity and conductivity. Resistivity of the wire. Another name, specific resistance, represented by rho. Resistivity or specific resistance. The resistance of the wire is directly proportional to the length of the wire what you are considering. More the length, more the resistance. And is inversely proportional to the area of resistance. So R proportional to L, R proportional to 1 by A. So I can write R is equal to, or R proportional to L by A. R is equal to rho into L. This rho we call it as specific resistance or resistivity of the wire. So rho is equal to RA by L. Unit of resistance here is ohms. Resistance unit is ohms. So unit of resistivity means ohm, area meter square, length meter, meter cancels. Ohm meter is a unit. Ohm meter is a unit of resistivity or specific resistance. Okay. Conductivity. Represented by sigma. Sigma is called conductivity. Sigma is 1 by rho. What is rho here? RA by L. So I can write L by R. Unit of sigma. Simply inverse of rho. What is rho unit? Ohm meter. So I can write ohm power minus 1, meter power minus 1. Ohm power minus 1, you can write it as mho meter power. Reverse, mh. Not everywhere you have to write, only at this point. Here alone, ohm inverse we are writing as mho. Meter inverse only. Any other unit power minus 1, you cannot inverse. Only in this conductivity unit alone, ohm inverse we are writing as mho. Simple concept. When you draw a graph, constant current, variable current. Constant current means time versus current when you draw the graph. As time increases, current remains constant. This is called constant current. Variable current. I versus T. Current is uniformly current is varying with time. current versus time. This is also uniformly varying. This is called alternating current. Yes. Variable current, time varying. That's all. Current is varying with time. Yes. Okay. Fine. In the case of Ohm's law, if you draw a graph between voltage and current, V and I, as V increases, I also increases. Nature of the graph is a straight line. Some cases, V versus I, it is slightly a curved. It is not a straight line, curved. These are the devices which follows exactly Ohm's law. So ohmic devices. Ohm's law slightly vary. Non-ohmic devices, diodes, transistors, and all non-ohmic devices. Electronics chapter we will discuss what is said to be a diode or transistor. The non-ohmic devices, exactly Ohm's law is not followed. Perfect form of Ohm's law. Okay. Resistors connected in series. Resistors in series, resistors in parallel. Series resistance, we will assume three resistors in series connected with a battery, plus minus R1, R2. In series circuit, current passing through is same. In parallel connection, potential difference is same. So this concept you should be very, very clear. Water flowing in a tube, I have got different taps. When you open the tap in the same line, you will get same amount of water. Whereas water connected in third floor, second floor, first floor, ground floor, when you open the tap, it depends upon the height. So pressure at the lowest point is maximum, highest point pressure is minimum, because pressure is HROG. Keep that example in mind and compare this. So water considered to be current. Amount of water flowing through the same pipe. Ground floor itself, you have got different taps, 5 taps. Same amount of water only. Similarly, resistance is same means series means current passing through is constant. So I can write V1, V2, V3 are the potential difference between the three resistors. Here, current I is constant. Therefore, potential difference V is equal to V1 plus V2. V1 is IR1, V2 IR2, V3 IR3. So V is equal to I into R1 plus R2 plus R3. Equation 1. Now, these three resistors You combine to form a single resistance, effective resistance or total resistance when connected in series. RS. Here also V is equal to IRS. Current is same. Here V is equal to I into R1 plus R2 plus R3. Current is same. Here also current is constant. Compare these two. IRS is equal to I into R1 plus R2 plus R3. I cancels. RS is R1 plus R2 plus R3. So the resultant resistance will be sum of the individual resistors. 2 means R1 plus R2, 3 means R1 plus R2 plus R3, etc. Rn. Nth resistors. Resistors connected in series. Next.